The internet is not always down because of IP addresses, routers, or some scary command line problem. Sometimes the first clue is right on the front of the switch. No link light. Before we touch any settings, what should we check first? Start with the cable. If the physical link is not working, the fancy stuff does not get a chance yet. Today we are talking about the physical side of networking. Copper cables, fiber cables, connectors, ports, and those little modules called SFPs. By the end, you will be able to look at a simple network situation and say, this needs copper, this needs fiber, or wait, the module and cable do not match. That skill matters for the CCNA, but it also matters in real life. Real networks still depend on real physical links. Let's start with the one you have probably seen before. This is copper Ethernet. The connector on the end is commonly called RJ45. Copper is the everyday choice for short local connections. Think of a laptop to a switch, a classroom PC, a home router, a printer, or an access point. Inside the cable are twisted pairs of wires. The twist helps the signal stay cleaner as it travels. For many twisted pair Ethernet links, a common design limit is up to 100 meters. That is plenty for a room, a lab, or many runs inside a building. Quick check. A laptop is 10 feet from a classroom switch. Copper or fiber? Copper. Simple, cheap, and perfect for that kind of short link. Now let's switch to fiber. Fiber optic cable does not send electrical signals through metal wire. It sends light through glass or plastic fiber. That makes fiber useful for longer distances, high-speed uplinks, and situations where copper is not the best fit. So if you are connecting two buildings or building a fast uplink between switches, fiber often becomes the better answer. Question: two switches are in different buildings. Which media would you usually choose? Fiber. The exact fiber and transceiver depend on distance and equipment, but the big idea is long link, think fiber. Here is the part that trips people up. Do not mix up cables, connectors, and modules. RJ45 is the connector shape you usually see on copper Ethernet. LC and SC are connector shapes used with fiber. An SFP is different. An SFP is a small transceiver module that plugs into a switch or router. Then the cable plugs into the SFP. So if someone says use the SFP, they usually mean use the SFP port and the correct module for the cable and distance. Mini match. SFP. Cable, connector, or module. Module. SFP is not the cable. Let's make this practical. When you choose a physical link, ask 4 questions. How far does the link need to go? What ports do the devices have? What speed do you need? And do both ends match? Scenario 1. A laptop is connecting to a classroom switch. Copper Ethernet with RJ45. Scenario 2. A switch in one building connects to a switch in another building. Usually fiber, with compatible transceivers on both ends. Scenario 3. A switch has an empty SFP slot and you need an uplink. You need the right SFP module first. Then you match the cable to that module. Now for troubleshooting. When the physical link is broken, start simple. Is the cable fully seated? Is it in the right port? Is the cable damaged? Does the link light come on? Is the run too long? Are the speed and duplex settings okay? Are errors increasing on the interface? For the CCNA, you do not need to become a fiber engineer in this episode, but you do need the troubleshooting mindset. A switch port has no link light. Should you check subnetting first or the cable first? Cable first. Physical layer first. Quick recap. 1. Copper Ethernet is common for short local links. 2. RJ45 is the familiar copper Ethernet connector. 3. Fiber uses light and is common for longer or high-speed links. 4. LC and SC are fiber connector types. 5. An SFP is a module, not the cable. Mini quiz. Question 1. Which connector is common on copper Ethernet? RJ45. Question 2. Is SFP a cable or a module? A module. Question 3. For a long building-to-building uplink, would you usually think copper or fiber? Fiber. Question 4. What is the first visual clue that a physical link is working? The link light. Next time, we move from physical links to logical addresses. That means IP addressing, subnet masks, and the part of networking that scares people way more than it needs to.